Okay, so today we will discover, or we will continue with chapter 4, which is Boolean algebra and digital logic. Okay, right. So today's topic is Boolean algebra and digital logic. Okay. Okay, so as you know, computer architecture deals with electrical signal, right? Represented by binary signal, which consists of two discrete value, which are 1 and what class? 1 and
0.
1 and 0. Okay, so electrical signal, represented in the form of binary, okay. Binary signal, consists of two discrete value, which is either 0 or 1, either 0 or 1. So you can copy this one first. Either 0 or 1. Boolean algebra is mathematical system for the manipulation of variables that can have one of two values. These are the one of two values lah. Which is either 1 or zeros. Right. So this one will resemble the concept of Boolean algebra. It will resemble the concept of Boolean algebra. Let me get the highlighter first. Algebra. Mathematical system for manipulation of variables. Right. So as you can see here, we may use several variables to represent electrical signals of 0 or 1. So the example of variables here, either x or y. So these are the example of the variables. The example of variables that we have here is either x, y, and etc. And others lah, others. Right. So for the time being, we have only two variable, which is x and y. So you may copy this earlier basic concept first. The Boolean algebra and the variables. Right. For the time being, we have two variables, which are x and y. Can you give other example of variables that we can have instead of x or y? Please, any of you give one example of other variables, others that I mentioned on top here. Instead of x and y, apa lagi kita boleh pakai? What else instead of x and y?
Z.
Z. You can also have z lah, right? Right. So this is the concept of variables lah. So let's say you have x, y, and z. So you have three variables lah, either x, y, or z. Or you can have w. You can have w here. All right. So for the time being, we focus to two variables lah, which is x and y. In formal logic, these values are true and false. True and false. So the true and false is represented by depends on the electrical signal, such as the one that we have here. Such as the one that we have here, either 0 or 1. So which one is true and which one is false? 0 true or 0 false? Can try.
0 false.
0 is false, correct. Siapa yang jawab tu? Bagi nama.
Wanita.
Again? Again, siapa nama? What about 1? True or false?
True.
True. Okay. So this is the two states. Okay. Okay. The formal logic. Okay. If the value is 0, it is false. If the value is 1, it is true. So I differentiate using different colors lah. Okay. In order easier for you to differentiate. Okay. So 0 is false and 1 is true. Colors now. Okay. Right. Okay, class. Are you clear so far? What you have discovered earlier? Are you clear? Jelas ke?
Yes, clear.
Okay, then in digital system, okay, okay, these values are on and off. Okay, high and low. So you can see here on and off and high and low. Okay, so we back to our example that we have seen here. Okay, this one I remove. Okay, so which one is on? 0 or 1 is on? Which one?
One.
Fine.
1 is on. Okay.
On.
Okay. What about 0?
Off.
Off. Okay. Right. Good. Okay. And then we have high and low. Which one is high and which one is low?
One is high.
One is high,
1 is high.
Zero
Okay.
is low.
And 0 is
zero.
low. Okay. Okay. So I have summarized here. Okay. The difference between 0 and 1. Okay. So I hope you can take note lah. Okay. 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 So 0 is either you can determine as false, off, or low. Okay. Okay. So 1 is equivalent to true or on or high. Use the similar color. Color. Okay. Right. Okay. So you can copy this concept. Let me reduce the size. Okay. Right. Okay, so this is the basic electrical signal lah. Okay, right? Okay. Okay, common Boolean operators. Now we have operators. Okay, just now we have digital system, and then we have the formal logic. Okay, then we have learned about Boolean algebra. Okay, right? So now we will explore about the operators. Okay, so do you have any idea the example of Boolean operators that we have, class?
And
Boolean operators. Okay. One example is what? Boolean operators.
and
N. Excellent. Okay. Okay. Selain pada N, instead of N, what else you have?
Or.
Or. Then, what else? Not.
Not.
Okay. Right. So this is the basic concept of a Boolean algebra that we are going to cover during our lecture session today. Okay. Okay, can you see this table, class? You can see this table, right? Okay, so the terms or the name of this table we call as the truth table, jadual kebenaran. Okay, right. The name of table is truth table, so you can copy lah. Okay. Okay, so this table we call as the truth table. Okay, so we have two variables. Okay, we have two variables and we have the empty right hand side row, right? Okay. Okay, we have we have empty right hand side column, right? Okay, so this column normally we put the operator. Okay, this part we put the operator. Okay, we put the Boolean operator. Okay, right. Okay, so just now you are telling me that the example of Boolean operators, okay, example of Boolean operators are either and or not, right? Okay, so we can have one example of Boolean operators. Okay, right? Okay, so maybe we can put it as Z. Okay, Z is equivalent to X or Y. X or Y. Okay, so this is this is what we call as output, okay, or this one we call as the Boolean expression, okay, right? So this part we call as output or we call as Boolean expression, okay, right? Okay, so you can do this way, x or y, okay, or later on we will see the other example, right? Okay, okay, so let's try our first example first, okay, right? Okay, okay, so in order for us to get the output, so this is what we call as the output, okay, okay, we need to have the input, okay, right? Okay, so the first the input that we should insert it, okay, within the truth table, okay, it depends on the variables, okay, right? If let's say we have two variables, okay, for the time being we have x and y, right? Am I right, class? X and y.
Yes.
Okay.
Yes.
So x and y is equivalent to how many variables, class? How many variables?
2.
2.
Two, right? X1 and y is the second variables. Okay, so this is equivalent to two variables. Okay. 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 So this part, okay, we call as the input combination. Okay, what are the inputs that we feed in order to get the equivalent output? Okay, so to differentiate, okay, this is what we call as the output, z equivalent to x or y. Okay, so you can copy this part first. Okay, let me differentiate using different color, maybe this color. Okay. Okay, right, so this part is what we call as the output, okay, and this part we call as input, okay. Let's insert, okay. Okay. So this one we call as input, okay, and this one we call as output. So I can combine this one, combine cell. Where is the combine? Okay, merge cell, okay. So I merge the cell again, okay. Okay, okay, so the x and y is the input and z equivalent to x or y, this one we call as output, okay, right? This one we use different color, okay. Okay, class, you may copy this part first, class, in half a minute, okay. I want you to copy the truth table first, okay. Okay, class, can you start copy now? Boleh? Okay, start copying this table now, because afterward, okay, we will do it step by step together, okay. Okay, we will try to solve this problem and fit the input, and we try to determine what are the outputs when we insert the relevant input. Okay, in half a minute, okay, I want you to copy this part, okay. Okay, maybe by 4:17 we will continue, okay. Okay, class. Okay, have you copied the first task I have given to you? Done, class?
Sir.
Done.
Done, sir.
Okay, any questions so far? Ada soalan ke? Right. Okay, so for this truth table, this is what we call as the truth table. Okay, I have differentiate between input and output using different colors. Okay, so X and Y is the input and Z is the output. So maybe I can center this one. Okay, right. Okay, so the binary signal is our input. Okay, so binary signal should be either in the form of value 0 or value 1. Okay, right. Okay, class. Okay, what do you think the input will be for X and Y for the first input combination? What do you think? What is the input?
Zero,
We should
zero.
fed the value either 0 or 1. Okay, what do you think the first input for X and Y?
0, 0.
0, 0, excellent. Okay, so this is our first input combination, right? Okay, so what about the second input combination, class?
0, 1.
0, 1.
1. Nama-nama, nak bagi markah. Siapa nama?
Alia.
Alia, okay. Right, the third combination, what is that?
1, 0.
1,
1,
0.
0. Nama? Nama?
Shafiqah.
Shafika, okay. Okay, maybe gentleman lah for the last input combination or for the fourth input combination. One gentleman, please. Give me the example of the fourth input. What do you think? Gentleman, I tak nak jawab.
1-1.
First, 1, excellent. Nama?
Syed.
Syed, okay. Right, so 1. Okay, do we have other input combination instead of the four combination? Ada lagi tak you rasa?
No.
Ada tak? No.
No.
Okay. Right. Okay. So then we can go into conclusion lah. Okay. Right. Okay. So in order to determine how many input combination that we should have, okay, the formula is you have to count how many variables. Okay. For this for this truth table, how many variable that we have, class? How many variable?
2.
How two variable, right? Okay, the formula is 2 power of x. Okay, 2 power of x. Okay, in which x is the number of variables. Okay, x is equivalent to number of variables. Okay, right? Sorry. Okay, the formula is 2 power of x. Okay, so how many variables that we have? Okay, maybe okay, x pun boleh lah. Okay, so how many variables that we have, class? How many variables?
2.
2, right? Okay, so 2 power of 2. Let me separate it.
2.
Okay, so 2 power of 2, okay. Okay, so we have 2 power of 2. Okay, so what is 2 power of 2, class?
4.
Equivalent to 4,
4.
excellent. Okay, right, equivalent to 4. Okay, this is equivalent to 4 input combination. Okay, 4 input combination. Okay, are you clear, class? Are you clear?
Yes.
How do you get 4 input combination? Why we didn't extend into 5 or 6 input combination? Are you clear? Are you clear, class?
Yes.
Yes.
Okay, so it depends on the number of variables that we have. Let's say we have x, w, x, and y. Okay, so how many input we have? How many variables? Sorry, how many variables we have? W, x, and y. Let's say we have w, x, and y. 3, right? Okay, so
Three.
what do you think? What is the number of input combination that we should use?
9.
9.
Huh? Berapa?
2.
2
2
power
power
of
of
3, kan?
3.
Right. Okay, so equivalent to what?
9.
9 ke? 2 power of 3.
8.
8. 8.
8. Okay, kalau tak ingat tekan calculator Okay. Okay, so 2 power of 3 is what? Berapa? 8, kan? Okay. Okay, so if we have w, x, and y. Okay, so it is equivalent to 3 variables. Okay, var is the variables. Okay, okay, therefore the formula is 2 power of x, which is for 3 variables. Then we have 8 input combination. Okay, we have 0 1 0 0 0, and then we have 0 0 1, and then we have 0 1 0. Okay, are you clear, class? Are you clear?
Yes.
Okay, now
Yes.
in maybe in 1 minute, I want you to figure out the output. Okay, what is the results if you do x or y? 0 or 0? What is the answer? What is 0 or 1? Okay, in 1 minute, because now in my place I'm having apa azan. Okay, then we will discuss the answer together. Okay, so please figure out the output, the answer here. Okay, meet again in 1 minute. Okay, class. Okay, do you have the answer, class?
Yes.
Okay. Okay, what is the answer? Siapa nak bagi bonus? I want to answer this bonus mark question. Sebelum soalan lebih susah. Okay. What is the answer for 0 or 1? Okay, now the expression is this one we call as Boolean expression. Okay, so the Boolean expression is Z is equivalent to X or Y. Okay, so this is what we call as Boolean expression. Okay, this is what we call as Boolean expression. Okay, Boolean expression X or Y. Okay, what is the the answer for X 0, Y 0, X or Y? What is the answer, class?
0.
0. Okay, what about 0 or 1?
1.
1, excellent.
One.
Okay, so in other words, okay, for OR gates, okay, so just now I tell you about Boolean operators, right? And or not. Okay, so another word for Boolean operators is what we call as the gates. Okay, Boolean operators also we call as logic gates. Okay, logic gates. Okay, right. Okay, so the logic gates may consist of and or not. Okay, okay. Okay, so in other words, okay, any input value that you OR with 1, the result will be equivalent to what, class? Any of the input that we OR with 1, what is the output?
1.
1.
Output will be 1. Okay, okay, let's say we have here sorry, 0 or 1, the output will be 1. Okay, 1 or 0, the output will be what?
1.
1. 1 or 1. Now we have both 1. What is the output, class?
1.
1. Okay, right. Okay, so for the symbol for OR, you can either put it as X or Y, or you can put it as X plus Y. Okay, right. Okay, so you have to differentiate this. When you talk about Boolean expression or Boolean algebra, okay, right, X plus Y is actually plus is equivalent to OR gates, right? Okay, so for OR gates, okay, you may use plus. Okay, but for plus, this is not a plus or addition. This is an OR gates. Okay, class, are you clear? Are you clear for OR gates? Clear, class? Okay, now okay, I want one of you to show me about the AND gates. Okay, right. Okay, to continue with this, okay, I want you all of you to copy this truth table. Okay. Okay, I want you to copy this truth table. Then I want any one of you to volunteer, and I will give with bonus marks. Okay, so the output. Okay, I want to put it as AND gates. Okay, AND gates. Okay, okay. So as usual, if you have two input, okay, the sorry, two variables, the input combination maximum will be 4. Okay, and what is the output? Okay. Okay, have you copied this truth table, class, for AND gates? So this truth table you name as the truth table, okay, for AND gates. AND gates. Okay, class, have you copied this one? Class, have you start copying this truth table, doing this truth table? Yes. Okay.
Yes.
So in 1 minute, okay, I want any of you to share the contents to give your answer, okay, about the Boolean expression, and then give me the output, the results after you perform, okay, the Boolean expression, or after you perform the logic gates. Okay, are you clear, class? Are you clear, all of you?
Yes.
Okay, anybody have any question? Anybody not clear what I'm asking you to do? Everybody clear, right? Okay, if clear, I give you 1 minute. Okay, then I want any of you, okay, to give the Boolean expression as well as to tell me what are the outputs and complete this truth table. So this is the popular question in your quiz or your midterm exam lah. Okay, so you will be this one will consist of so many marks. Okay, the marks for creating the truth table. Okay, then the marks to list down the input combination. Okay, the variables, and then the marks for the output or the results. Okay, so maybe by 4:34. Okay, I would like to have any one of you to volunteer to share your answer. Okay,
Yes,
so
yes.
you may snap it or you can use Microsoft Excel as mine. Okay, so do it now by 4:35 lah. We will see your answer. Okay, class. Okay, so okay, I want to give bonus mark for any of you that can show me your answer. Okay, anybody volunteer? Tell me your name. Then, okay, cepat. The earlier you volunteer, the earlier we can finish our lecture today. Okay, anybody volunteer? Salah tak apa. It's okay.
Yeah.
Anybody?
Me,
Izzah.
Okay, nama?
Syafika.
Syafika. Okay, Syafika, boleh share content you tak? You punya truth table. Boleh tak?
Saya guna kertas.
Guna kertas. Boleh juga you snap, lepas tu you share. Boleh tak you share? Or you want to share to what? Dekat WhatsApp pun boleh. Share kat WhatsApp pun boleh. Mana yang senang. Boleh, Syafika. Senang tak kalau share kat WhatsApp? Group WhatsApp.
Boleh, tapi
You share kat group WhatsApp.
saya just buat dekat sebelah tu je. Saya tak salin complete the box.
Truth table you salin tak?
Saya salin untuk yang tadi tu. So yang untuk R tu. But yang N tu saya just tulis dekat sebelah dia je. Saya tak buat
Ni
satu
je.
kali box.
Okay,
Yes.
boleh juga. Kita tengok Syafika punya. Salah tak apa. We learn from mistake. Okay, Syafika nak WhatsApp ke macam mana? Nak hantar ke WhatsApp group?
Saya tengah buat dekat WhatsApp. Wait.
WhatsApp group G1 ke G2
Yes.
Syafika? G1 ke G2?
G tu.
G2, okay. Dah hantar dah?
Wait.
Okay, sekejap. Kalau dah hantar beritahu Okay. The rest pun boleh be prepared Mana tahu saya panggil saya point any of you to share your answer. Okay, while Syafika is trying to snap and share her result. Okay, anybody else want to get a bonus mark and share your answer? Cepat. Anybody else? You're waiting for Syafika. Yang lain?
Sure, I have a question.
Yeah. Faisal, is it?
Yeah.
Okay.
Is
Faisal, what
Ant
is the
like
answer?
Adam?
Come again?
I told you Ant. Is it like Adam?
Okay. N is like multiply. The concept of n, it is like multiply. Any number that you multiply with 0, the answer will be 0.
You. Okay.
Is it clear, Faisal?
Yeah.
Okay. Have you learned these gates before during your high school?
No, the one and 0 I didn't learn about it.
Okay. Then you can try. Okay. Anybody else want to volunteer? Okay, Syafika ada share. Kita tengok Syafika's answer. Okay, this is the answer, Shafiqah's answer. Okay, right. Okay, so this is what Shafiqah have shared with me. Okay, so you can ignore the x or y lah. So we focus to x and y. Okay, we refer to the first answer. Okay. Okay, first input is x0, y0, x and y. Okay, the answer is 0. Is it true, class? Is it true?
Yes.
True.
Yes, 0 and
Yes.
1. Okay, x0, y is 1. Okay, what is the output?
Zero.
0. Okay, so it means that the conclusion is any input that you end with 0, the answer will be
Zero.
0. It is like multiply. Okay, what about if 1 and 1? What is the answer?
One.
1.
One.
Okay, so this is what we call it as the answer for the truth table. So excellent, Shafiqah. Bonus mark for Shafiqah. So this is what I'm waiting for from you lah. Okay, I hope you can participate like Shafiqah. If possible, maybe you can share your screen to show your answer. Maybe from next question onwards, I will ask somebody to share the answer. Okay, so please be prepared when I give you time to figure out the answer. Okay, right. Okay, so well done, Shafiqah. Kita go on with the OR table and truth table. Truth table. Okay, so in other words, okay, the expression like Shafiqah has shown us is z is equivalent to x and y. Okay, you may do it this way, or you can just put it as x, y. Okay, so x, y is like x and y, or sometimes we put as dot in between. Okay, okay, so this is the symbol for AND gates. Okay, are you clear, class? Are you clear?
Yes.
Okay,
Yes.
so 0 and 0 is 0. What about 0 and 1? What is the answer?
Zero.
0. Okay, and then the following one, 1 and 0.
Zero.
What is 1 and 1?
One.
Okay, so I hope you have understood this part. Okay, right. The complement represent the inverse of variables and indicated y over bar. The complement of A is A bar. Okay, okay. So let's say we have variable A. Okay, let's say we have a variable A. Okay, let's say we have variable A here. Okay, and we have a complement for A. Okay, okay. So for complement of A, we put it as A bar. Okay, we put it as A bar. Okay, A bar means that on top of A, they have the bar. Okay, they have the bar. Dia ada songkok. Okay, they have kopiah on top of A. Right? Okay, are you clear, class? Are you clear what I'm trying to tell you?
Yeah.
Okay, right.
Yes, clear.
Okay. So same goes to also A and A bar. We also need to produce the truth table. So you can I have to put a table here. Where are tables? Okay, right. Okay. So okay, for the time being, how many variables that we have, class? How many variable we have? How many variable?
One.
1, because A and only A, right? So 1 is equivalent to 2 power of 1, 2 power of x, x which is equivalent to 1. What is 2 power of 1, class? What is 2 power of 1? Dah lupa dah. What is 2 power of 1, class?
Two.
2, okay. So 2 power of 1 equivalent to 2. So how many input combination that we should have here?
Two.
Berapa? 2. So what are the relevant input values?
Zero. And one.
0 and 1. Okay, let me minimize the size dulu. Okay, taruh bawah sikit. Okay, so the the input value is either 0 or 1. Okay, 0 or 1. Okay, right. Okay, as you know here, okay, this is A bar. Okay, the A bar is what we call as complement. Complement for A. Okay, complement for A. Okay, complement for A is equivalent to A bar. Okay, can you see the bar here, class? Can you see the bar?
Yes.
Right. You can see the songkok dia. I think this one I should remove first. Let me remove this one. No border. Okay, I should put border here. The border, outside border, outside border. Okay. Okay. So we have input is A bar is the output. Okay. So we know that. Okay. The input of A we need to complement. You remember, right? We have done a complement in first complement. Can you still remember, class? Still remember?
Yes.
Okay. What is the complement for 0? What is the answer for A bar?
1.
1. Okay. Okay. What about input? If input is 1, what is the output or the complement for 1?
0.
0. Excellent. Okay. Right. So this is what we call as the complement, in which you have done in the two's complement. You have done the first complement operation. Okay. Clear? Okay. So this is the example. Okay. So this is the example that we have done earlier lah. Okay. Okay. So the Boolean operators can completely described using the truth table. So you have done the truth table. Okay. The AND operator and Boolean product. Okay. Right. So the product is the result lah. Okay. The OR operator is the Boolean sum. Okay. So you can see here. Okay. Sum kan. Okay. It looks like sum, but it is not sum actually. It is OR. Okay. It is OR. Okay. Because if you do 1 plus 1, is it the answer is equivalent to 1, class? Is it correct? If you do the manual addition, 1 plus 1, is it 1 or 0? What is the answer
No.
for 1 plus 1? 0, right? Okay.
Yes.
Okay, so this is just the concept lah. Okay, for OR operator, we can use the plus symbol, the sum symbol, but it is not sum, it is OR. Okay, for AND operator, okay, you use a product. Product is equivalent to multiply. So 1 multiply with 0 will get 0. 1 multiply with 1 you'll get 1. Okay, for NOT operation is designed by an overbar. You can see overbar here or X bar. Okay, X bar is what you call as the NOT lah. Okay, X bar. So if the value of X is 0, the complement of 0 is 1. If the value of X is 1, the complement of X is 0. Okay. Okay, so for the time being, we will be doing the more complex Boolean expression. Okay, now we have 3 variables. Okay, we have 3 variables. Okay, right? Okay. Okay, let me copy this one first lah. Lambat. Okay, right. Okay, class. Okay, let's draw the truth table together. Okay, so while I'm giving you lecture, I want you to straight away draw the truth table, and then we figure out the answer. Okay, figure out the answer together. Okay, right. Okay, so first of all, you create the input variables. Okay, and then you can put that as the one of the output, which is z bar and x z bar. Okay, right. Okay. Okay, my question is, how many variables that we have here, class? How many variables?
3.
So what are the variables, class?
X,
What are the
Y,
X,
Z.
Y, Z.
X, y, or z, right?
Z.
So you can have x, y, or z. Okay. Okay, so then we have final output. Our final output will be, okay, so this one we can put as f or any variables lah. Okay, so this one will identify the output. It's equivalent to okay, x. Okay, so output will be this one lah. Okay. Let me just copy this one. Okay. Okay, so our final output will be this one. Okay. Okay, X a bit bigger. Okay. Okay, the output is X Z bar plus with Y. Okay. Right. Okay. Okay, now we have three input combination, right? Okay, so how many sorry, we have three variables. Okay, so how many input combination that we should have here, class? How many input combination? Because we have three variables, right? 8. Okay, so we have 2 power of 3. Okay. Okay, 2 power of 2 power of 3, okay, is equivalent to 8. Okay, so we need 8 input combinations. Okay, 8 input combination. Okay, the first input first input combination, and then second one. Okay, just we go through together lah. Okay, what are the first input combination, class?
0, 0, 0.
0,
0,
0,
0.
0. Excellent. Okay, so let me make it as centralize this one. Okay, X YZ is 0, 0. Okay, siapa yang bagi 0, 0 tu? Nak bagi bonus mark nama?
Yeah, 0, 1.
Alia.
Alia. Okay. And then after that, second one. Okay, gentlemen. Siapa tadi? What is the
0,
second
0, 1.
input combination? 0,
0, 1.
0, 1. Name? Nama?
Face up.
Nama? Okay. Okay, tak apa. Kita teruskan. Okay, the next one. The third. What is the third? Kita nak pergi laju sebab nak balik awal Okay. What is the third combination?
0, 1, 0.
0, 1, 0. Okay. What else?
0, 1, 1.
0, 1, 1. Okay. So kita buat lagi. Then what else?
1, 0, 0.
1, 0, 0. Okay.
1, 0,
1,
101.
0, 1. Okay. What else?
1, 0. 1, 1, 0.
1, 1, 0. What else?
1, 1, 1.
1, 1.
1, 1. Okay. Now we want to prove whether our formula is correct or not. Okay. We want to prove if we have three variables. Okay. Is it correct that we have 8 input combination? Is it true, class? Betul ke? True?
Yes.
Okay. So this is the fourth input combination. Okay. So this is the fifth. This is the sixth, and this is the seventh, and finally this is the eighth input combination. Right? Okay. So you have proven that if you have three variables, okay, so we have 8 input combination. So let's make it as all boxes. Okay, right. Okay, and then you put it as the z bar. Okay, z bar. Okay, z bar. Okay, and then the following one will be x z bar. Okay, right. Okay. Okay. So this one we consider as x z bar lah. Okay, x z bar. Okay, because difficult for me to put the bar at the top. Okay, so this one is x z bar. Okay, or not z. Okay. So this one. Okay, so this is one box. Supporters. Okay, right. So this is the output. Okay. Okay, so we try to solve this answer one by one from input combination 1 until final input combination. So this one I differentiate using different colors, maybe this color. Okay, the the even input combination I put it as white color. Okay, and the odd input combination I put as green color. Okay, it's easier for us to see. Or maybe I didn't put this one first. Right. Okay, so now, okay, we want to get the full marks for this boolean for this truth table. Okay, what is truth table? Truth table. Okay, right. Okay, the first one is we want to get the z bar. Okay, okay, so we refer to the value of the z or z. Okay, okay, what is the current value for z, class? What is the current value? Zero. Okay, what is the answer for z bar? Okay, because it is the complement for z. Okay, right? Okay, and then the second one is x z bar. Okay, x we end with z bar. Okay, so now we have the z bar, right? We have the z bar. Okay, we end the value for z bar with the value of x. Okay, are you clear, class?
Yes.
Okay,
Yes.
what is 0 and 1? What is the answer for 0 and 1?
Zero.
Zero.
Okay, everybody clear? Okay, until this point, anybody, everybody clear? Anybody not clear or want to ask me question? Everybody clear, class? Is it clear?
Yes.
Nobody.
Yes,
Everybody
sir.
clear? Okay. So can we proceed or okay, can we proceed to the following input combination and the output? Can?
Yes.
Okay. Okay, now for the second input combination, okay, I refer to white color. Okay, okay, the value of z is what, class?
1.
1. What is z bar?
Zero.
0. Very good. Okay, right. So now we do the expression, the Boolean expression for x and z bar. Okay, so we have the value for z bar. You end with the value of x. Okay, so 0 and with 0. What is the result?
Zero.
Zero.
Okay. Okay. Can I ask you to finish up the rest of the 8th combination for z bar and x z bar? Can you do it?
Yes.
Okay. So
Yes.
in 1 minute, okay, I want you to show me your answer. Okay, so I would like to have volunteer for me to give bonus mark. Okay, so we will discuss the answer by 4:56. Okay, right. So everybody try it. Okay, class. Everybody have finished fill up the z bar and x z bar, class. Everybody finish?
Yes.
Done? Okay, anybody volunteer to share your answer? Volunteer.
Yes. Yes.
The question is still simple. The following question much more difficult. Better you volunteer now.
I want to volunteer.
Okay, siapa nak volunteer?
Yeah.
Give your name. Tell me your name and then okay.
Faisal.
Come again.
Fa-
Now
Fa- Faisal.
Faisal. Okay, Faisal. Can you share your screen? The answer for this one. Then we
Okay.
check together.
On WhatsApp.
Or you send to WhatsApp. Faisal G1, right?
Yes.
Okay, Faisal, you have shared your answer?
Oh,
G1,
shit, no.
Check G1. Okay, Faisal, have you shared your answer? Not yet. Okay. So this is Faisal's answer. So let's check together. Okay. Okay, so for the first input, okay, class, we check together. Faisal answer. So doesn't matter whether your answer is correct or wrong, still will be awarded with marks. Okay, so this is the learning process lah. Okay, class, can we check together the the third combination, which is 0, 1, 0. Okay, the z bar is 1. Okay, and then the x, okay, and with z bar, okay, answer will be 0. Okay, so the z bar, the value of x is 0. Okay, 0 and 1, answer will be 0. Okay, correct for the third combination. Okay, class, what about the fourth combination? Okay, let me fill up here. So this z bar in accordance to Faisal, the answer will be 1. Okay, and x z bar, the answer will be 0. Okay, everybody agree with Faisal answer? Class? Is it correct?
Yes.
Yes.
Yes,
Okay, what
correct.
about the fourth combination for Faisal's answer? If you do it in the form of Excel, or it is clearer lah. Okay, but it's okay. Good effort, Faisal. Okay, what about the fourth input combination? 1, 2, 3, 4. Okay, the X bar is 1. Okay, okay, the Z bar is 1. Okay, and then X and Z bar, 1 and 1, answer will be 1. Okay, right. Okay. Z bar is 0. The fourth combination is 0. Okay. Okay, is it correct, Kras? This one? Is it correct?
Yes.
Same with your answer. Okay, what about X and Z bar? X is 0. Okay, and Z bar is 0. The answer will be what?
0.
0. Okay. Okay. Okay, let's check. Faisal answer 1, 2, 3, 4. Okay. So what about Faisal's answer? Is it correct? Is it correct? Is it similar with my answer, class?
Faisal tak cukup room.
Okay, not enough one combination, is it?
I missed one line, right?
You missed one line. Okay, it's okay. It is what we want to discover actually, because when we didn't do it, okay, we didn't realize that we make a mistake. Okay, very good try, Faisal. Okay, right? Okay, okay. For the rest, are you clear this one? Are you clear? How to fill up the truth table, class?
Yes.
Yes, sir.
Okay, because this truth table consists of so many marks. Okay, let's say each boxes consists of half marks. So you count how many boxes we have here. Let's say if you have 20 boxes, okay, just to produce a truth table is already 10 marks. It is a lot of marks. So make sure you know how to complete the truth table. Are you clear, class? Are you clear?
Yes.
Yes, sir.
Okay, let's try to finish up the final result, which is the final expression is x z bar plus with y. Okay, now we have the x z bar, right? Okay, and then we have the plus. Okay, what is the meaning of plus here, class? What is the gate here?
Or.
Oh, so it is equivalent to OR gates. Okay, right. Okay, so the plus is actually equivalent to OR gates. Alignment center. Okay, so OR is equivalent to plus equivalent to OR gates. Okay, right? Okay, so x and with z bar, you have the answer here, and then you need to plus with y. So plus y is actually x z bar OR with y. Okay, so this one, okay, 0, you OR with y. Okay, are you clear, class? So
Yes.
use different color, this one. Okay, so in order to get this one, okay, I use different color. Okay, this one. Okay, you need to to OR. Okay, let me put the battery. Okay, for the time being, finish up the rest of the Boolean expression. Okay, for x z bar plus with y. Okay, so you need to or the x z bar you or with y. So this one I use this color. Okay, okay. Oh, sorry. Okay, this one. Okay, okay. You need to or with y. Okay, you need to or with y. Okay, in order to get the final results. Okay, right. So you find out where is the column for x z bar, which is here. The answer will be 0. Okay, 0 or y. What is the value for y, class?
Zero.
Zero.
Okay, so here 0 or 0. What is the results for x z bar plus y? What is the result?
Zero.
What about this one?
Zero.
Zero.
Here. Okay. Okay. 0 or 0, the answer will be
Zero.
Zero.
okay. So what about this one?
Y.
Okay. 0 or 1. What is the answer?
Y.
One.
1. Excellent. So you know how to do it, right? Okay, so fill up the rest lah. So I believe you have understood lah this part. Okay. So means that this one discuss about this truth table. Okay, about this truth table. Okay, class, are you clear? Are you clear, class?
Yes, sir.
Yeah. Okay. We go on to the next part. Next slide. Where is my Excel? Okay, right. The next one is the laws of Boolean algebra. Okay, right. So this part is actually just an introduction. Okay, so the details, the description, okay, will be discussed during our lab session, either online or asynchronous. Okay, right. Okay, you need to remember the laws of Boolean algebra. Okay. Okay, the first laws is commutative law. Okay, okay, commutative law. Okay, apply to addition and multiplication. Okay, for addition, okay, the commutative law in terms of result, the order in which variables are odd make no difference. Okay, okay, is it true a plus b, a or b is equivalent to b or a? Is it true, class? Is it true?
Yes.
Okay, so okay, let's say you still want to prove it, you can use the truth table. Okay, you can use the truth table. So maybe I give one example. Okay, where is the table? Ini besarkan juga. Right. Okay, so we have here. Okay, we have A, B, A, and then we have B, and then we have A plus B. Okay, and then we have is it equivalent to B plus A? Okay, B plus A. Oops, sorry. B plus A. Okay. Okay. If we have two variables, so input will be 0, 0. Okay. What next after 0, 0? 0. After 0, 0, what is the next input, class? 0,
0,
0, 1. Okay, and then 1,
1,
0.
0.
Finally, we have 1 and 1. Okay. What is A or B? 0 or 0? What is the answer, class?
Zero.
0.
0. Okay. Is it equivalent to B or A? Sama tak? Is it similar?
Yes.
Yes.
Okay. So this is how you prove the commutative law. Okay. if the midterm exam question asking you to prove the commutative law of addition, okay, therefore you can explain or you can give the answer using the table. Okay, you can use the truth table. Okay, are you clear, class? Is it clear?
Yeah.
Okay, or now we try to use A and B. A and B. Okay, right. A is 0, B is 0. What is A and B, class? Like multiply. What is the answer?
0.
0. 0 and 0 answer will be 0. What about B and A? What is the answer?
Why? Am I?
0.
What is the answer? 0,
Zero.
right? B and A, 0 and 0. Also, the answer will be the same. Okay, let's try this one. Okay, A is 1, B is 1. A and B. What is the answer, class?
1.
1. Okay, what about B and A? B is 1,
1.
A is 1. 1. Okay.
1.
Okay, are you clear, class? How you want to prove the commutative law or laws of Boolean algebra? Are you clear?
Yes, sir.
Yes.
Okay, you can prove the laws of Boolean algebra by using the truth table. So if the question in an exam asks you to prove the law, you can use the truth table. Okay, right. Okay, so this is the other example for associative law. Okay, so let's try to do it together. So we have A, B, and C. So we insert here C. So I clear this part. Okay, in 1 minute, I want all of you to figure out the truth table to prove this associative law. Okay, for okay for A plus B, sorry, A plus with B plus bracket B plus C is equivalent to bracket A plus B plus with C, right? Okay, so let's do it together. So this one we clear first. Okay, in 1 minute, I want you to discuss your answer. Okay, so we have A, B, C here. Okay, and I give a little bit of gap. Okay, so I have A. Okay, plus. Okay, so this one A is okay. Okay, the first thing is you need to do B plus with A. B plus with A. Sorry, B plus with C. Okay, B plus with C. Okay. And then you can do A plus with bracket B plus C. Okay, right. Okay, so the other one is A plus B. A plus B. A plus B. Okay. Okay, and the final one will be minimize. Okay, A plus B, and then the final one will be bracket A plus B, okay, plus with C. Okay. So this one plus C. Right. Okay. Okay, our intention is to prove that this one is equivalent to this one. Okay, class. Can you understand what you need to do, class? Do you understand how to do
Yeah.
it?
Yeah.
Okay,
Yes.
very good. Which one? Which one? Okay. Okay, so you want to prove that okay, A plus with a bracket B plus C, it is equivalent to bracket A plus B plus C. Okay, so this one here. Okay, okay. Without wasting time, we do it together lah. Okay, right. What is the first input? First input. Okay, what is the first input class?
0,
A 0. What about B?
0,
C 0. C
0.
0. Okay, then you fill up the rest. What is the second?
0, 0, 1.
0 0 1. Okay. Okay, what is the third? Oh, no,
0, 1, 0.
okay, so the third, fourth, fifth, sixth, seven. How many input combination altogether for three
8.
variables?
8.
Okay, so what is the third combination? 0. What is the third combination? 0
0, 1, 0.
0 1 0.
0, 1, 0.
0 1 0. Okay. Okay, so we see this expression, right? Okay, before we can prove that a plus bracket b plus c is equivalent to bracket a plus b plus with c. Okay, you can show the workings like this. You do the b plus c first. Are you clear, class? Are you clear?
Yes.
Okay, what is b plus c or b or c? B 0, c 0. What is the result?
0.
0.
Okay, right. The second input. Okay. Okay. B is 0, C is 1. What is the result?
1.
1.
1. Very good. So this one. Okay. So I center this one. Center first. Okay. This one also I center lah. So center all. Okay. Right. So we have done a B plus C is 0. Okay, you remember during your high school or during your matriculation or during your STPM or diploma time. Okay, whenever you see this mathematical expression, okay, which one you need to do first? Which one you need to do first? Is it all addition or you need to do the bracket first? You need to do the bracket first, right? Am I right?
Yes.
Okay, so that's why you get it. You figure out the B plus C first, and then you do the addition. A plus with B plus C. So for this one, A you or with B or C. So what is A class for the first input?
0.
0, right? What is B or C?
0.
0. What is A plus with bracket B plus C? What is the result? 0 or 0? What is the result?
0.
0. Excellent. Okay, so we have a look to the second input combination. Okay, second input combination. Okay, okay, we need to or A plus with B plus C. Okay, so what is value of A class?
0.
0. What is B plus C?
1.
1. Okay, 0 or 1. What is the result here?
1.
1. Okay, so the rest I believe you can do it by yourself, right? Am I right, class? Simple, right?
Yes.
Okay, so we straight away figure out the other part of equation so that we can shorten the time. Okay, right? Okay, for this one also, okay, is it you have to do A plus B plus C or we have to do A plus B bracket first? Which one?
A plus B bracket
A
first.
plus B bracket first. Okay, okay, what is A or B? What is the value of A? 0.
0.
What is the value for B? 0, right? Okay, 0 or 0. What is the result?
0.
0.
Okay, right. We go to the second example. Okay, A plus B. The value of A is 0. What is B class? 0,
0.
right?
0.
0 or 0. What is the result?
Result
0.
is 0.
Okay, now we want to figure out the answer for bracket A plus B plus with C, right? Okay, so we have bracket A plus B is 0. We need to or with C, right? Am I right, class? Is it true?
Yes.
Yes.
Okay, so the A plus B is 0. You or with C. What is the value of C?
0.
0.
0 or 0. What is the result?
0.
0.
0. Okay, let's figure out the second row. Okay, okay, you need to do A plus B bracket plus with C. Okay, A plus B is 0. What is C class? What is C?
1.
1.
1.
1 or 0. What is the answer?
1.
1.
based on these two row or two input combination, can you prove that for associative law, okay, A plus with bracket B plus C, it is equivalent to A plus B bracket plus with C? Is it correct? Is it similar?
Yes.
We can see the answer here. Can you see? The answer is the same. The input the same, right? The answer is same, right? This one also the same. Are you clear, class?
Yes.
Okay.
Yes.
So
Yes,
this is to
sir.
prove that if, let's say the question in exam asking you to prove associative law, you can use the truth table. Okay. I hope everybody clear about this concept and how to prove using the truth table. Okay. Any questions so far? Any question? Everybody clear?
Yes.
Or anybody have any question? Clear? Right. Okay. Also, you can use the ending process lah. Okay. And also the same. Okay. A and with B and C. So which one you should do first? Is it A and with B or B and C first? Which one first?
B and C first.
B and C first, yeah. Right. The concept is just like your mathematical operators. Okay. You need to do the bracket first. Remember the concept of BODMAS. Okay. Right. Okay, so this is the example of laws of Boolean algebra, distributive law. Okay, so A plus B, okay, plus with AC, it is equivalent to A, okay, and with B plus C. Okay, okay, this is equivalent to A and with B plus C. Okay, do you know how to prove this expression, Boolean expression, class? Or how you know how to prove this distributive law based on the example that I have given earlier? Can you, class?
Yes.
What should we do?
Yes.
We need to draw what? The
Truth table.
The
Truth
truth table.
table. Okay, so let's try to do for the initial step lah. Okay, so we want to prove that A plus B plus AC it is equivalent to A and with B plus C, right? So here instead of BC, you change to AB. Okay, right? So this one you can remove lah. Okay, still we have the same input combination. Okay, because we have A, B, and C, right? Okay, for this one, you need to insert another one. Insert. Okay, so this one you can put which is AC, right? Okay, what is the the distributive law that you want to prove? Okay, AB plus with AC plus with AC, B plus AC. Okay, and then the following one is A. Okay, the following one is B plus C. B plus C. Okay, and finally, you want to end. Okay, you want to end A, B plus C. Plus. Okay, do it together with me, class. Do it together with me, so that you can do it and finish it soon as possible. Okay. Okay, what about the input combination? Is it correct? Is it the same input combination, class?
Yes.
Yes.
Right. Okay, so we want to prove that okay, this is not the one that we want to refer. We add another one. So this one I neutralize again. Put it as no field. Okay, right. So the one that you want to prove is we insert another insert. Okay, so the one that we want to prove is AB. Okay, AB plus what, class? Plus AC, right? Okay, so this is the one that we want to prove. AP plus AC. Is it equivalent to speed up. Is it equivalent to A times with B plus C? Okay. 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 You understand what you need to do, class? Are you clear here?
Yes.
Okay. Any question? Any question? No, eh? Right. Okay, let's do it together. Okay, firstly you do the AB. Okay, A is 0, B is 0. Okay, what is AB means? AB means what? A and
0.
And
A and B. Okay,
and B.
so this is equivalent to A and B. So AB means that it is equivalent to A and B. Right. Okay, so AB is equivalent to A and B. Okay, so AB is equivalent to A and B. Okay, right. Okay. Okay, what is A class? What is the value for first input combination? What is the value of A?
0.
0. What is B?
0.
0. Okay, 0 and 0. What is the result?
0.
0.
0. Okay, right. What about A and C? What is the value of A class?
0.
0. What is the value of C?
0.
0.
0. 0 and 0. What is the result?
0.
0. Okay, good. Okay. Okay. Then now you need to perform the addition, or you need to odd. Okay, you need to odd these two expression. Okay. AB plus with AC. Okay. So what is the meaning of plus here, class? Plus is what?
Or.
Or. Okay, 0 or 0. What is the result?
0.
0. Oh, terlebih satu eh. Okay. Okay, so I have okay. So 0 and 0 result will be 0. Is it correct, class? Is it true?
Yes.
Okay, now we figure out B plus C. Okay, what is the value for B, class?
0.
0. What is value of C?
0.
0. Okay. 0 or 0. What is the result?
0.
0. Okay, so we want to figure out A and with B plus C. Okay, B plus C is 0 and with A. Okay, bracket means N. Okay, are you clear, class? Bracket means N. Are you clear?
Yes.
Yes.
0 and with A. What is the value of A here?
0.
0.
Okay, so 0 and 0, what is the result?
0.
0.
Okay, let's try through the second one. What is AB, class? We go a little bit faster. What is
0.
AB for the second input combination?
0.
0. What is AC?
0.
0.
A or C? A or
0.
C? What is the result? A and C,
1.
sorry. A and C.
1.
0.
0.
My mistake. A and C. Faisal. It is not A or C, Faisal? My mistake. Okay.
Yeah.
A and C. A is 0, C is 1. So the result will be 0. Correct? Okay. Okay, what about A, B plus B plus AC? What is the result?
0.
0.
0.
Okay, what is B plus C for this one?
1.
B 0. Okay,
1.
plus with C 1. Okay, 1. We have 1. Okay, what if you BC and with A? A is 0, right?
0.
Okay, 0 and with 1. What is the result?
0.
0.
0. Okay, can you prove this one? Same, right? Okay, A plus B, sorry, AB plus C, it is equivalent to A and with B plus C. Same, right? Am I right?
Yes.
So this is to prove the distributive law. Okay, are you clear, class? Jelas? Are you clear?
Yes.
Okay. So I think I will go the last part. Sorry. I go the last part. Okay, last two parts lah before we end our session. Okay. Okay, for this I have to open the pin maybe. Okay. Okay. Now I want to show you the logic gates, right? Okay, actually later on, okay, you can use the multimedia logic software in order to draw the gates. Okay, it is much more interesting lah, because instead of you draw the gates, so this one we call as the circuits or the gates. Okay, okay, instead of you draw manually using a pen or whatsoever, you can use you can just drag and drop the circuits from the multimedia logic software. Okay, you can drop it and then you can do the input combination. Okay, so this one we call as the circuit diagram. Okay, we call it as circuit. Okay, we call as circuit, or this one we call as the logic, the gates. Okay, circuit, or we call as the gates, logic gates. Okay, call as the gates. Right. Okay, and if you see this one, okay, this is equivalent to all gates. Okay, this one is equivalent to all gates. Okay, you can copy or you can snap. Okay, if you see semi-oval, okay, this is AND gates. Okay, this is the AND gates. Gates. It's over lah because I use the mouse. Okay. Okay, as you can see here, we have B, C, and A, right? So the B, C, and A is the input. Okay, so actually, one logic gates, normally we put two inputs. Okay, we have two inputs, right? Okay, okay, so the one that you have here, we call as inputs. Okay, call as input. Okay, okay, so this is the fundamentals of computer circuit. Okay, so the earlier types of computer is being drawn by using this diode or using the gates, right? Before you have the powerful microprocessor, the early days of computer is using the gates in order to perform the computation or perform the computer processing. Okay, and okay, we have two input and we have another line here. Okay, right? Okay, the line here we call as what class? Okay, this one we call as input, right? Okay, what about these two line? We call as what? Output. Very good. Okay, lawan untuk input is output. Okay, so this one we call as output. Okay, right? Okay, and this is the output lah. AB plus AC is the output. AN with B plus C is an output. Okay, right. Okay, so this one I think I discuss later lah, because it is already late afternoon. Okay, right. Okay, so for the last part, we will go through together about the rules of Boolean algebra. Okay, this one also you can prove by using the truth table. Okay, can use the truth table. Okay, right. Okay, the rules of Boolean algebra. A plus 0, the answer is equivalent to A. Okay, how to prove this the first Boolean algebra class? How to prove this first rules is true? Using what class? Using what? Cepat, we want to go back early. How to prove? Just now I have shown you, right? How to prove the Boolean algebra, right? How to prove these rules of Boolean algebra? Using what?
Truth table.
Truth table. Excellent. Okay, so let's try the first example. The first rules. Okay, first rules is we have A, capital A. Okay, right? Okay, how many a variable we have class? How many variable?
One.
One. Okay, therefore we only have 2 power of 1. What is 2 power of 1? 2,
Two.
right? Therefore we have two input combination, which is 0 or 1. Okay, and then we have A plus 0. A plus 0. So plus 0 is actually or 0, A or 0. Okay, so this is A plus 1 is equivalent to A or 0. Okay, right? Okay, so let me get the where should I get the table? Okay, okay. Okay, so if you do A or 0, okay, what is the result for A or 0 class? Okay, for this first input, 0 is A is 0. What about the answer for A or 0? What is the answer?
0.
0 or 0, the answer will be 0.
0.
A is 1. Okay, We all with 0. 1 or 0? What is the answer?
1.
1.
1.
Okay. Okay. Is it proven that? Let me copy this one. The first rules of Boolean algebra. Okay. Okay. Is it proven that A plus 0 is equivalent to A, class? Is it proven?
Yes.
See here? A
Yes.
plus 0.
Yes.
Okay. It is equivalent to A. Right? Okay. Now you clear how to prove this Boolean algebra. Are you clear, class?
Yes.
Yes, sir.
Okay, so let's try other example. Okay, maybe A plus 1. We try A plus 1. Try A plus 1. Okay, try A plus 1. Okay, I want you to do together. You do it together. Okay, and then we figure out the answer. Okay, right. So this one you change to A plus 1. Okay, A plus 1. Okay, A is 0. Okay, what is the answer for 0 or 1? What is the answer?
1.
1. Okay, right. A is 1. Okay, what about 1 or 1? What is the answer?
1.
1.
One.
Okay. Okay. Is it proven that second rules for Boolean algebra? Put it here. Okay. Is it proven that A plus 1, the answer will be 1?
Yes.
Yes.
Yeah, right? Okay, A plus 1, the answer will always be 1. Are you clear? Can you see?
Yes.
A plus 1, answer always will be 1. Okay, so this is how to prove the Boolean algebra. Okay, so this one you can do it by yourself. Later on, I want you all of you to submit your truth table to prove the Boolean algebra. Okay, let's say here we have the double bar. Double bar means that we complement 2 times. Okay, right? So we have here A, we have here A, okay, and then we have A bar, okay, right? And then the A bar, you bar again, A double bar, means that you complement twice. You complement twice. Sorry. Okay, right. So now we have oh, okay. Okay, for A double bar dia ada kening, dia ada eyebrow, 2 eyebrow. Okay, A only 1 eyebrow, only 1 kening, right? Okay, so now we have the value of A is either 0 or what, class? 0 or
1.
0 or 1. Okay, 0 or 1. Okay, what is A bar, class? What is complement for A?
1.
1.
1. Okay, okay, what is the complement for 1? Sorry, what is
0.
1?
0.
0. Okay, okay, then we double eyebrow, 2 kening, ataupun kita complement twice. Okay, now we have complement 1. Okay, after we complement again, what is the result for A double bar?
0.
0.
When you complement 1, the answer will be 0. Excellent. When you complement 0, what is the answer?
1.
1.
1. Is it proven? Is it proven the rules of Boolean algebra? A double bar is equivalent to
Yes.
0.
Yes.
Yes, right? Okay. Satisfied, right? Puas hati, Okay, so this is how to prove the Boolean algebra. Okay, so this is being developed by by the scientists earlier lah. Maybe if you be the following scientist, you can name it as Shafiqah algebra, for instance. Okay, so based on their name lah. So algebra is from the old scientist named Al-Jabbar. Okay, so we call as algebra. Okay, okay. So are you clear, class? How to prove this Boolean algebra, class?
Clear, sir.
Okay.
Yes.
Clear. So, okay. Basically, what you see here. Okay, A plus 0 is 1. A plus 1 is 1. Okay, A n with 0. Answer will be 0. Okay, and then we have A plus with AB is equivalent to A plus with A bar and with B is equivalent to A plus B, right? Okay, so all of this you can prove using truth table, right? Okay, okay, what can you conclude from this? Okay. What can you conclude from? Okay. Okay. What can what can you conclude from rules number 10 here? A plus with A and B is equivalent to A. You can see. Can you see the simplification, class? Can you see that we can simplify the circuit? Can you see here? From A plus AB is equivalent to A. Can you see the simplification? Class? Class, can you see the simplification? We simplify from longer Boolean expression becomes the shorter Boolean expression. Can you see here? Class?
Yes.
Okay. So in other words, that is the idea of learning computer architecture. So what you can see in the during the old days, the size of computer that can only perform a basic mathematical operation such as add, subtract, and so on is the size of a building. Okay, but currently you can see the size of computer is as small as your smartphone, right? So in other words, that is the idea of learning computer architecture. Okay, okay. The first thing is we want to improvise the performance. We want to produce the speedier processor. Okay, okay. As well as we want to produce computer devices which is smaller and smaller in size. So that is the reason why we learn about Boolean algebra, rules of Boolean algebra. Okay, are you clear, class? Is it clear?
Yes.
Class?
Yes.
Yes, sir.
Okay, so that is the thing lah. Okay, we learn about computer architecture or computer organization. Okay, to nurture you to be the future scientist in order to produce or to create a new computer devices. Okay, which is better in performance as well as smaller in size. Okay, so you can simplify the logic gates lah. Okay, right? Okay, then you can you can prove the Boolean's identity De Morgan's theorem. Okay, A B okay is equivalent to A bar plus with B bar. Okay, A and B bar. Okay, this one is A and B bar. You must end first, then only you complement it. It is equivalent to A bar plus with B bar. Okay, right. Afterward, I want you to prove this one. Okay, okay. The complement of two or more odd variables is equivalent to n of the complements of individual variables. Okay, okay, means that A or B bar, it is equivalent to A bar and with B bar. Okay, so in other words, you have to OR first, then only you complement. Okay, so I want you to prove this De Morgan's theorem lah. That like I have explained to you. If you are the scientist, you can change the name lah. Okay, Sykes theorem maybe. Okay, right. So the guy or the scientist that produced this theorem, the name is De Morgan's. Okay, right. Okay, so you need to prove this one using what? How to prove this De Morgan's theorem, class? Using what?
Truth
Two
table.
table.
Truth table. Jelas eh? Okay. What else? Okay. So I believe that is the end of our lecture today lah. Okay. Right. Okay. So before we end our session, any of you have any question? Ada soalan?
No.
No. Clear, right? Everybody clear?
Yes.
Yes.
Okay. So later on, I want
Just
you
one
to
question. Just one question.
I want all of you to prove the De Morgan's theorem. Okay, and I want you to submit to the link in Ulearn that in which I will provide later. Okay, if
Sir.
no more question, right? Anybody have any question before we end
Yes.
our session? No?
Yes.
No question, eh?
No.
Me. Can you hear me?
Yeah. Any question?
Yeah.
Faisal. Yeah. What is
Yeah.
question?
I noticed in this lesson that you didn't include more than one number
Which
in
one?
the bar.
Which one?
Like when you add 1 to 1, it equals 1, 0, right?
You are referring to which slide, Faisal?
I mean in the schedule.
Which slide? Which slide?
For example, if we have 1 plus 1, it
Huh?
equals 1, 0, right?
1 plus 1. Okay. Okay, we are talking about logic gates. Okay, logic gates, plus means or.
Okay.
Okay, for logic gates, it is different with arithmetic. Arithmetic, 1 plus 1, we have 0, carry forward 1.
It's
Is it clear?
different from
It is different. This one is we call as the logic. Logic. Okay. Logic is either and or not. Okay. If 1 plus 1, okay, 1 plus 1, okay. Oh, sorry. 1 plus 1. Okay. Okay. This number is not addition. This is an or. If you are talking about logic gates. Okay. It is 1 or 1.
Okay.
Okay, Faisal. Is it answering your question?
Yeah.
So this is different with the one that you have done last week. The one that you have done last week is the arithmetic. Okay, the one that you have done last week is arithmetic. Okay, it depends on the question. If the question asking you about arithmetic, okay, it is different with logic. So the one that we are learning today is what because as a logic operation. Okay, is it clear, Faisal?
Yes.
Okay. So, okay.
Thank
Any
you.
further question? Faisal, any further question from you?
No, no.
Okay, thanks
Nothing.
for asking the question. Okay, the rest, do you have any further question or no more question? Class, any of you have any question? No, eh?
No.
Okay, with that, I think we end our session. Okay, thanks for your time. Okay, see you again during the next session. Okay, thank you. Assalamualaikum. Good afternoon.
Waalaikumsalam.
Thank you, sir.
Dadah.
Thank you,
Thank you,
sir.
sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.